Welcome to Selection with Sathi. Today we will learn C programming basics, data types, printf, scanf and operators. Whether you are preparing for GATE, campus placements, or just starting out with programming, these fundamentals are absolutely essential. Let's get started. First concept, data types in C. C has 4 primary data types. Int stores whole numbers and takes 4 bytes of memory, with a range from -2 to the power 31 to +2 to the power 31-1. Float is for decimal numbers with single precision, also 4 bytes, giving about 6 digits of accuracy. Char stores a single character in single quotes and takes just 1 byte. Every char has an ASCII value from 0 to 127. Double is like float but with double precision, 8 bytes and about 15 digits of accuracy. Remember, int and float are 4 bytes, char is 1 byte, double is 8 bytes. Second concept, printf format specifiers. Printf is the standard output function in C. You use format specifiers to tell it what type of data to print. %d prints an integer. %f prints a floating point number with 6 decimal places by default. You can control precision with .nf, for example, %.2f shows exactly 2 decimal places. %c prints a single character and %s prints a string. For hexadecimal output use %x, for octal use %o, and for pointer addresses use %p. To print a literal %sign, use $%. Third concept, scanf for input. Scanf reads formatted input from the keyboard. The critical thing to remember is the ampersand operator. For an integer, you write scanf %d, $x. The ampersand gives scanf the memory address where it should store the value. For a string using a character array, you do not need ampersand because the array name itself is an address. The most common beginner mistake in C is forgetting the ampersand. This causes a segmentation fault, which means your program crashes. Always double-check that you have ampersand for int, float, char, and double variables. Fourth concept, operators in C. C has 4 main categories of operators. Arithmetic operators are plus, minus, star for multiplication, slash for division, and % for modulo. Modulo gives the remainder, 7% 3 equals 1. Relational operators compare values, double equals, not equals, less than, greater than. They return 1 for true and 0 for false. Logical operators are double ampersand for and, double pipe for or, and exclamation for not. They support short-circuit evaluation. Bitwise operators work on individual bits, single ampersand for and, pipe for or, caret for XOR, tilde for not, and shift operators. Bitwise operations are very fast and commonly used in systems programming and embedded code. First example, variable declaration and printf. Let's declare 3 variables, int age equals 25, float pi equals 3.14, char grade equals capital A in single quotes. To print the integer, we write printf age %d \n, age. This outputs age :25. For the float, printf pi %.2f \n, pi. This outputs pi :3.14 with exactly 2 decimal places. For the character, printf grade %c \n, grade. This outputs grade :a. Each format specifier matches the variable type, that's the key rule. Second example, scanf with multiple inputs. We want to read two integers from the user and print their sum. First declare int a, b, sum. Then call scanf with %d space %d comma ampersand a comma ampersand b. When the user types 10 space 20 and presses enter, a gets 10 and b gets 20. Calculate sum equals a plus b, which is 30. Finally print sum equals %d comma sum prints sum equals 30. Notice both variables needed the ampersand operator. Third example, sizeof operator. Sizeof tells you how many bytes a data type occupies in memory. Sizeof int returns 4. Sizeof char returns 1. Sizeof double returns 8. This operator is evaluated at compile time, not runtime, so it has zero performance cost. Sizeof is essential when doing dynamic memory allocation with malloc. You write malloc n times sizeof int to allocate space for n integers. Remember, sizes can vary across platforms, so always use sizeof instead of hard-coding byte counts. Fourth example, bitwise operations. Let's take 5 and 3. In binary, 5 is 0101 and 3 is 0011. Bitwise and 0101 and 0011 equals 0001, which is 1, and gives 1 only when both bits are 1. Bitwise or 0101 or 0011 equals 0111, which is 7, or gives 1 when at least one bit is 1. Bitwise XOR 0101 XOR 0011 equals 0110, which is 6. XOR gives 1 when bits are different. A cool XOR trick, A XOR A always equals 0 and A XOR 0 always equals A. This lets you swap two variables without a temporary variable. Quick tips for C basics. Tip 1. Always initialize your variables before use. Uninitialized variables in C contain garbage values, which can cause unpredictable behavior. Tip 2. Use %.nf to control decimal places in printf. %.2f shows two places, %.0f shows none. Tip 3. Never forget the ampersand in scanf for primitive types. This is the #1 beginner bug in C. Tip 4. The XOR swap trick, A XOR equals B, B XOR equals A XOR equals B swaps without a temp variable. Great for interviews. For more concept videos like this, download the Selection with Sathi app. Like and subscribe. Thank you.